All right, today we're looking at something pretty incredible. It's called Quantum Swarm VLA, and it's this amazing project that's basically smashing together quantum computing and AI. And why? To tackle one of the most time-sensitive challenges you can imagine, disaster response. When every single second counts. So let's get into it and see how this thing actually works.
So, first things first, when seconds count. To really get why this project is such a big deal, you have to picture the scene. We're talking floods, wildfires, earthquakes, situations where the clock is ticking and the difference between a fast response and a slow one isn't just about efficiency. It's literally about saving lives.
Okay, so the systems we have now, they're pretty good, but they hit some serious walls. There are really three big bottlenecks. First, you've got a pure math problem. Trying to calculate the best routes for a whole swarm of drones, it's just too slow. Second, our current AI can get, confused. It might look at a muddy river and scream catastrophic flood, which, you can imagine, sends resources to the wrong place. And finally, there's a huge single point of failure risk. If one drone's sensor glitches out, it could trigger a massive false alarm across the board. So yeah, these are exactly the problems this project is designed to crush.
So with problems like that, how do you even begin to solve them? Well, you don't just tweak the old system, you take a quantum leap. And that's not just a fancy phrase. We're talking about a completely new way of thinking about the problem.
And this is where it gets really cool. If you look at the evolution, classical AI models like Florence 2 are powerful for sure. They got us to about 90, maybe 92% accuracy. But in a disaster, that 8 to 10% gap is where things can go horribly wrong. So the new idea, this quantum hybrid approach, is super smart. It doesn't ditch the classical AI. No, it keeps it for the stuff it's great at, and then it plugs in this quantum core to do the heavy lifting, to solve the problems that were basically impossible before.
But how does adding quantum actually help? Well, the secret sauce, the superpower here, is something called Hilbert space. I love this analogy. Imagine you've got a tangled mess of different colored threads all jumbled up on a table. Trying to separate them is a nightmare, right? But what if you could lift them up into the air, into a 3D space? Suddenly they just fall apart, easy to see. That's exactly what Hilbert space does for data. It gives the AI this massive, multidimensional space to work in, making it ridiculously good at spotting the subtle difference between, say, muddy water and a catastrophic flood.
Okay, so how does this whole thing actually fit together? Let's pop the hood and take a look at the architecture.
And here it is. This diagram shows you the whole flow, and it's actually pretty elegant. You see on the left, an image comes in from a drone. That image gets fed right into the heart of the system, that hybrid quantum core. Then, after all the magic happens inside, you get these crystal clear, actionable outputs on the right. We're talking about dispatching rescue teams, sending out critical alerts, no ambiguity.
So let's break down that hybrid quantum core. It's really a three-step process. Step 1, a classical AI, in this case ResNet, acts as the eyes. It looks at the image and pulls out all the important visual details. Then, step 2, it hands those features over to the brain of the operation, the quantum neural kernel, or NQK, which makes the really tough call. And finally, step 3, you have this quantum consensus protocol. This is brilliant. It basically forces the whole drone swarm to agree on what they're seeing, which is how you eliminate those dangerous false alarms. Okay, let's zoom in on that quantum brain for a second, the NQK. This is where the real quantum magic happens. It takes that classical data and encodes it onto qubits. Then it uses entanglement, this wild quantum property, to find hidden connections in the data, patterns that a classical computer would just be blind to. The outcome? A classification that is way, way more confident and accurate.
All right, I know what you might be thinking. This all sounds amazing, but is it just a bunch of theory? Well, this is the best part. We're moving from code to reality because this system isn't just a concept on a whiteboard. It's real, it works, and we've got the results to prove it. Just look at this table. It's a perfect side-by-side. The old way used Florence 2 for vision. The new way has the hybrid ResNet and NQK. The old way had classical consensus. The new way has quantum Byzantine consensus. But here's the real kicker. Path planning. They went from a standard search algorithm to a quantum optimization algorithm, QOAA. This isn't just a patch. It's a complete top-to-bottom quantum overhaul.
And look, the proof is in the pudding. The backend server connecting the classical and quantum worlds, it's live. Check. The hybrid classification pipeline, it's successfully piping data from one to the other. Check. A real functional dashboard where you can upload an image and see what's happening. Live and working. Check. And the SMS alerts, fully integrated. Check. The core of this thing is built, it's connected, and it's running. And how fast are we talking? Get this. under 2 seconds. In simulation, it takes less than 2 seconds to go from an image coming in through the whole hybrid classical quantum process to a final decision. That is just incredibly fast for this level of analysis. But it's not just about making the decision fast. What about getting help where it needs to go? That quantum optimization for path planning. It's showing a potential quadratic speedup. Now, what that means in the real world is about 5 times faster. Think about that. Getting drones to a disaster zone 5 times faster. When you're talking about rescue operations, that's not just an improvement. That's a complete game changer. That's the difference between life and death. And this just makes it all so real. This isn't some hypothetical output. This is an actual SMS alert the system sent during a test. Critical, flood detected, dispatch 5 teams. It's simple, direct, and completely actionable. It's exactly the kind of clear, no-nonsense information first responders need when chaos is breaking loose. So we've seen the problem, we've seen the solution, and we've seen that it actually works. So what's the big picture here? What does this mean for the future? And this is the most important thing to understand. This isn't just about making a better tool for one specific job. What we're looking at here is a whole new paradigm. It's a blueprint for how we can take the classical computers we know and love and supercharge them with quantum processors to go after the world's most complex, most wicked problems, the stuff that we used to think was just unsolvable.
And that leaves us with a really exciting question to think about, doesn't it? If this kind of hybrid quantum AI can totally revolutionize something as complex as disaster response, what else can it do? I mean, think about the other huge challenges we face: designing new medicines, modeling climate change, understanding complex financial markets. This hybrid approach might just be the key that unlocks solutions we can barely even imagine right now. The potential here is absolutely massive.